Okay. You three attended the test, right?
Yes,
Yes,
sir.
sir.
Okay, fine. So let me ask it directly then. Did you guys face faced any difficulty in any of these questions?
No, sir.
Sir.
Uh, I didn't get the response of understood the response of Jitendra. Did you said yes or no?
No, sir.
Okay. Harshit, and any difficulty in any of the question?
No, sir, all questions are easy.
Okay, fine. So tell me if you guys have any doubt in what we have studied until now.
Sir,
Sir,
no doubt until
actually,
now.
sir,
Mm-hmm. Yes,
sir, I had NSO last week. Can we discuss the question paper?
you missed
Me too, sir.
the.
I had Science Olympiad last week.
Mhm.
NSO exam, sir. Me too. I too had it.
Sir, can we discuss the
Okay,
question paper?
okay. Jitendra, you were there in the last class, right?
Yes, sir.
Okay, fine. So is it okay if I discuss that question paper with you?
Yes, sir.
Okay. So last week I think we had this paper, light, right?
Yes, sir.
Did we had light? Okay. Okay, then start with question number one. What is light and how does it travel? Tell me. Just answer me. What is light and how does it travel? Okay. Tell me. Did you guys attended that test?
Yes, sir.
Okay, you attended. And Harshit?
Sir, I did not attend.
Okay, you did not attend it. Okay, good. Rohit and Karthik is also there.
Sir,
Fine.
light
So
is a form of energy which travels in a straight line.
perfect. It is a form of energy which allow us to see objects.
Sir,
Yes,
so Sunday test was on chemical effects of electric current, right?
which it was on this Sunday only. So, so you guys were saying about this Sunday or the previous Sunday?
Sir, what I asked is for NSO exam, ma'am.
Okay, your NSO exam was on which date?
Sir, around last month. Last month it was there.
Okay, so due to NSO exam, you missed that test or class.
No, sir.
Okay,
We are asking you to discuss NSO exam question paper.
okay, NSO exam question paper. Fine. Where can I find that question paper? Do you have it with yourself?
Just a second, sir. I'll check.
So, okay, you find it. Okay, it is not available in the internet. So, you guys like create if you have the hard copy of that question paper, create a soft copy and send it to me. In the next class, we will discuss. Right now, we have sufficient numbers so that we can proceed with the syllabus. Is it okay if we proceed? We will discuss that question paper in the next class.
Okay.
Okay. How many of you have appeared for that exam, NSO exam? Okay,
Sir,
Vinisha. Okay, only Vinisha appeared for NSO exam. Harshit, okay. Okay, fine. Then let me continue with the chapter. And Rohit and Karthik, tell me if you have any difficulty in any of these questions.
No, sir.
No, okay. Karthik, any difficulty?
No, sir.
Okay. Okay, then tell me what we have studied until now in this chapter of chemical effects of electric current. Which terms we have came across? What?
conductors and insulators.
Okay, fine. Conductors and insulators. What else?
Protons, electrons, neutrons.
Okay, good. Protons, electrons, and
Sir,
neutrons.
resistance.
Electric
What?
current.
Sir, resistance,
Resistance.
high resistance and low resistance.
Okay, good. Resistance, and it can be high, it can be low, and we also came across electric current.
Electric current.
Okay, what else? Have we
Electrical charge.
learned about tester? What else?
Electric charge.
Electric
Charge.
torch.
Charge, sir.
Charge.
Okay, electric charge. Electric charge. Simply say it as charge only, not electric charge, but say it as charge only. We have came across charge also. Okay, what else? Do we have anything left? We have seen tester, we have seen conductor, insulator. Okay, we have seen resistance also, and we have also seen the voltage in last to last class. We have seen voltage. Okay, so all of you know about voltage, right?
Sir, did we discuss about ions?
Ions.
Yes, sir.
Yes, we have discussed about plasma. Plasma, we have we say that as ions. Okay, so there like in we have discussed about filament also. Filament, which is used in bulb. Okay, where were we? Okay, I was saying about filament. So filament is the part of the bulb which glows, right? So if we make a bulb, then filament is this part. which has some resistance, and when we supply current, this filament glow. It glows. It glows. Why? Because of, tell me, how it is glowing? Due
Because
to
of
which
heat.
reason?
Heat.
Because of heating. Yes, and we call it as heating effect. Okay,
Sir, I have a doubt.
yes, ask.
Sir, what is the means in LED bulbs we see some greenish color, red color thing
Okay,
over the uh, filament, right? What is
okay. In LED, there are different colors. This is not correct diagram. LED, draw it like this. Okay, so you must have seen that different LEDs produce different colors. Okay, so different LEDs produce different colors. So any of you know the reason behind this phenomena, that why these LEDs glow different, these LEDs produce different colors? Anyone know? So when we discussed about light in the starting, we discussed that how different wavelengths are responsible for different lights. Okay, so different lights, like there are different lights have different wavelengths. So if the wavelength of if the wavelength of emitted light is different, the color it emit is also different. These LEDs all work on the phenomena of semiconductors. Okay, how they work on semiconductor? When we supply current, there is a diode inside this. Okay, you do not need to go in depth of this diode and all. You will came across this phenomena in the 12th class. Let me give you a brief idea. So these LEDs contain a diode. What does diode mean? There is a small rectangular plate. Okay, this rectangular plate has a division between it. It contains some positive charges in one side. It contains some negative charges on other side. And this plate is of semiconductor material. Okay, this plate is made up of semiconductor material. So when we apply current, so this middle part, the partition between this is a barrier. We call this as barrier. So you know that these charges are free. They move from one place to another. But because of this barrier does not allow electrons from move from right to left and protons from move left to. But when apply current, due to this, these electrons move from right to left, and these protons, or in this case we call them as holes. Okay, holes also carry positive charge. And let me not confuse you much. Let's call them proton only. So when we apply them current, they the electron move left to right and right to left. So it is the designing of these diode. When when these LEDs are prepared, these diodes are designed like this, that they produce light of different wavelength. If these diodes are designed like that, they need to produce blue light, so they have specific, like some specific characteristics. We say characteristics. They they deposit more electron in this side or more proton on this side. That depends on their how they design. But it is this diode, this small rectangular chip, which is present inside this LED. When we pass electric current, due to this passing of electric current, these electron and proton move from one side to another, and due to this movement, the light is generated, and this light is different colors. Harshit, are you clear with your doubt?
No, sir, I was asking what is the green color part which covers this. So can you open one's chemical effects of electric current chapter?
Yeah.
Sir, in that, yes, sir, that green color or yellow color, red color part, what is that?
This is the outer layering.
Yes, so
Okay,
what is the outer layering made of?
it is made of I think glass only, glass or some other material. Let me see how what it is made of. There are two wires, lead wires. Okay. Hmm. So like in when we talk about bulb, okay, when we talk about bulb, that bulb is mostly made up of glass. Okay. In LEDs, I think the outer layering is made up of silicon. Okay. The not LED, I'm sorry, the which we bulb, which different kind of bulb, the LEDs bulb, the big one, the outer layering, I think it is made up of silicon. And this I need to know what it is made up of. Wait. Okay, so this layering is made up of plastic and glass. Okay, the outer part is of plastic or glass. That depends on different LEDs we are using. Okay,
Okay, sir.
so fine. Okay, so why I bring this bulb part again? Because there are some bulb which glows due to phenomena of plasma also. Do you guys know about plasma? What is plasma? Anyone? I have explained plasma, I think 2-3 times. Tell me, what is plasma?
So it is the fourth state of matter.
Okay, and what is there in this matter, in this fourth state? So these are highly energetic ions, highly energetic ions. These are highly energetic ions, which we call as plasma. So you know that element like solid can be solid can be broken into two ions, like one as positive and one as negative, right? You know about this thing. Have you read about periodic table?
What,
Have you
sir?
read about periodic table?
Yes, sir.
Okay, great. So if we take any element in the periodic table, there are first of all, the periodic table has different elements present in it. Okay, can you tell me the number of elements which present in naturally
Sir,
state.
do you mean the reactive series?
Not reactive series, but the periodic table. Let me show you. And I'm not aware in which class it is introduced.
Sir, I had it last year.
Okay, last year. That means it started with 7th class. Is it?
Yes, sir. In my school, they taught in sixth also.
6th also. Okay. Okay, periodic table. Uh, Let me know if you hear any noise from my background. Okay, at any point. Not
Sir,
sure.
it's very blurry.
Yes, yes. It's blur. Wait, let's search it on Google Chrome.
Sir,
Sir,
I sent one in the Zoom chat. Could you check if it's fine?
Wait. What you have sent in? Okay, okay. The picture only. Can you see it now?
Yes, sir, now it's more clear and
sir,
visible.
Yes, Harshit.
sir, there are more than 1 or 3 elements, right?
Sir, there are
Um,
118, right?
Yes, sir.
Yes.
117.
Okay. I too forgot how many elements are there.
Yes, sir. It's 118. Sir, it's mentioned in the first one, the OG.
Okay, first one. Okay, 103 are here, and it is 118. Okay, fine. So there are 118 elements. I like left this chemistry long time ago, so I forgot. So there are 118 elements in this periodic table. And can you tell me how many of them are occurring naturally? Okay, so there are two
Sir,
type of
98.
Sir,
elements.
around 98 or 97 occur naturally.
Okay, so 94 actually,
Oh.
if I'm correct, because this one I know. Hmm. Okay, 94 it is correct. So 94 of the elements present in this periodic table occur naturally, which means that we
Sir,
can
I
find
have
this.
one doubt.
Mhm.
Sir, under rubidium, what is that CS?
Cesium, it must be cesium. Okay, rubidium, and it is cesium.
Cesium. Okay, sir.
Can you see it now?
Yes, sir. Sir, like,
It is cesium.
sir,
Mhm.
in our textbook, there's one reactivity series which has very few metals, like from high to low. The teachers
In,
never told us about the periodic table, but she just mentioned about it. We
okay,
don't
she
have it in the
mentioned.
textbook. Yes, sir.
So she must have mentioned up to 20, I think, up to calcium. Do you know about until calcium?
Yes, sir. It's there in the textbook also, sir.
Okay, it is there. Fine. So let me ask one by one. Uh, let you all guys tell me if you have not heard about periodic table. Venisha, have you heard about the periodic table?
Yes, sir.
Karthik,
Yes, sir.
Jitender, Jitender, do you know about periodic table?
Yes, sir. I have heard it, sir.
Okay, you have heard. So let me tell you a brief about this periodic table. So actually, there are many elements that exist in our surrounding. Okay, so there are two type. One that naturally occurred, other that is human made. So how we distinguish these? So naturally made, that I obviously mean by the name also, that these are present in our surrounding and we have found these elements while we were exploring our planet, exploring our planet or exploring our uh, atmosphere. The uh, some of these elements are present in solid state, some are present in liquid state, some are present in gaseous state.
Sir, I
Okay,
have one doubt.
yes.
Sir, what is the atomic number of beryllium? Do you know what the number is?
Beryllium, let's see.
4.
It must,
4. I think so.
yes, it is 4. No, atomic number is 2, atomic mass is 4. Okay, sorry. Atomic number is 4. Hydrogen, helium, lithium, beryllium, 4.
Okay, sir.
Fine. So these elements are present in three states, solid, liquid, and gas. So when scientists were exploring our planet and our ecosystem, our atmosphere also, they came to know about these elements. So they like did a systematic arrangement of these elements. You must be wondering why hydrogen is uh, placed here, why lithium is placed here, why sodium is placed here, why sodium is not placed in the right side. So this
Sir,
periodic table,
is it placed according to the atomic number or something?
no, not atomic number, but their nature. Okay, the type of nature they exhibit. So all of the elements which are present in the left, these are metals. Okay, and all of these elements which are present in the right, up to this, we say this as 17th group.
Sir, then what about the ones in the middle, like in between?
These are known those metalloids. Okay,
Okay, sir.
which exhibit the nature of metal also and non-metal also. And the this last one, this we call as 18th group. This group contain all of gases. Okay, this group has gases. So helium, neon, argon, krypton, xenon, radon, or and last is ognase, something like that. So
Sir,
these
what is it called again? Like 18th group?
18th group. Okay, so you do not need to go in detail. I'm just telling you a brief only. There is a separate chapter for periodic table in your ninth class and 10th class. Also in 11th, 12th also. There is a separate chapter in which they will tell you that how this periodic table started in the starting, like in 80s, in the 1800 century, that the periodic table was very small, only few elements. Then it evolved in 1900, then it evolved in 2000. So now people are experimenting with the elements which are already present. So what the scientists are doing, they are trying to do experiment on the elements which are existing in nature, and they are trying to merge it or separate it, with the help of which new elements are generated. So these new elements are not naturally, but actually humans have did some experiment and they have created these human made elements. So that's why we say that out of 118 elements, there are 94 only which are natural, and apart from it, all other these elements are created in labs, which are not naturally occurring. Okay, So this periodic table has systematic arrangement. On the left we have metal, on the right we have non-metal, and on the rightmost the group, which we say the column, the rightmost column has all of the gases. In the middle we have metalloids, which are metal and non-metal. Okay, so let me tell you one thing. So you need to learn up to 20 elements, up to 20, and I give you 2 weeks. Okay.
Okay, sir.
Do you guys know about calcium?
Yes, sir.
Yes, sir.
Okay, leave it then. Leave it then. I think it is not significant right now. Maybe in class 9th, I will ask you to learn. So let me tell you to do one thing, that you guys go through these first 20 elements. Okay, first 20 elements, and in your 9th and 10th class, your teacher will tell you to learn these 20 elements. Okay, these are on, must be on your tips, because these come again and again in your chemistry. So let me start. First
Sir,
one is hydrogen. Yes.
sir, all the elements are placed according to their atomic number, right?
Not atomic number. Like, yes, we say that atomic number. Okay, but
Sir, is it related to their like for hydrogen is on top since it's the most reactive chemical? Is it
no,
because
no, we hydrogen is not in a top due to it is most reactive. There are other elements also which are more reactive than hydrogen, like let's say sodium. So sodium is very much reactive. When it is placed on open air, it catches fire. Okay, so sodium is also more reactive than
sir
hydrogen. So it is
sir in the first 20 elements the most reactive one is sodium, right?
uh, yes, I think most reactive is sodium. It depends on the outer surrounding also, that is it we are asking in open air or we are asking in water. Okay,
Sir, what about magnesium?
magnesium.
Yes,
Hmm.
sir.
So magnesium also, no, magnesium is not that much reactive as that of sodium. Like sodium catches fire in open air, but magnesium does not. Okay, so yes, these are arranged on based on the atomic number. Okay, these all are arranged on the base of atomic number, but their position is coming like this. Like you can do one thing, that you place hydrogen here. Okay, and then start numbering it as like 1, 2, 3, 4, 5. Okay, so this the the position which they are placed is unique. It is based on the properties they are showing. So if I'm saying that lithium, sodium, potassium, rubidium, cesium, and francium, they are placed in this column, I'm saying it, these are placed in this column. Why? Because they are showing similar kind of properties. Okay, they show similar kind of properties. That's why they are placed in a single column, in the same column. Then we start with the numbering. The first one is hydrogen, second one is helium, third one is lithium, fourth beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Okay, so these 20 are most important up to class 12th. I don't know about further, like I have left chemistry after 12th. So up to class 12th, these are most important, and you must remember these.
Sir, so we don't need to learn all the other ones in the.
Other one also come in handy, like when I prepared for JEE. Okay, when you appear for a competitive exam like JEE. So in that education level, you need to learn this whole column. Okay, you had to learn this whole column, and there are some short trick also to learn. Let me say, like, I remember about this one. In Hindi, we learn this with the help of like beta mange car scooter, baap roye. What does that mean is the son is asking for car and scooter, and the
Then the
fa
father is crying.
father is crying. Yes, like this is in context of dowry. Beta mange car scooter, baap roye. So the son is asking for dowry, and the girl's father is crying. So like that. There are different ways of learning all these column. Okay, fine. So this is all about periodic table, and remember this thing that you whenever this periodic table is like shown to you by in your class, start learning these elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, uh, uh, phosphorus, sulfur, chlorine, argon, potassium, calcium. So these two, I remember these two until now also. Fine.
Mm.
Okay. So I was asking about plasma, the highly energetic ions. So this plasma also, there is some bulb also which contain plasma. Okay, positive, negative, positive, negative. So we, like, you must have until now learned that is filament bulb, filament bulb. There is LED bulb, and there is also a plasma bulb. So this is only for your general knowledge that there exists a plasma bulb also, where inside bulb there is a plasma, and plasma are highly energetic ions, which is the fourth state of matter. Fine. Let me go through the NCRT. So we have read until here, okay, up to this part, and before that I think we have revised everything: heating effect and the tester and the weak current. Okay, tell me one thing: what is the unit of current?
Sir, unit, by unit, do you mean the
Unit of current
Unit
is ampere.
ampere. Okay, very good. By unit, I mean that whenever
The
let me
current
say,
flowing through a unit area.
yes, okay, correct. So by unit, what I mean is that, like, when you measure your height, you always say that your height is in 6 foot 10 inch, okay, or 4 foot 5 inch, or you say 180 centimeter, 1.8 meter. Okay, so what we say, this foot, meter, centimeter. So these all are units of length. Okay, we whenever we say whenever we represent length, we always represent with the help of foot, meter, centimeter, or inches, right? Okay, or in kilometer, or in miles. So these are units of length. Similarly, the unit of current is ampere. So whenever you talk about current, like, let's say if you are talking that how much current is flowing through this wire, so you will always say that it is like 2 ampere. You can never say 2 alone, because alone 2 has no significance. If we attach ampere to it, that means the current is flowing to it. And if I say 2 volt is present in this wire, can you tell me what does this mean?
Can you repeat the question? Can you repeat the question, please?
I'm
2 volt.
asking,
Okay.
I'm saying
That
that
means that okay. That means that 2 volt of pressure. I mean, pressure is being applied. 2 units of pressure is being applied.
not pressure, but 2 volt potential difference is there.
Okay.
What does
So
this
between the
potential?
so between the negative terminal and positive terminal, there is the difference of
Yes,
2.
Yes. So whenever we say about current, then we talk about flow in wire. And whenever we talk about potential difference, that is always talked about between two ends.
Sir,
Okay.
and how is the voltage of current increased in electrical appliances? Is it by decreasing
How,
the amount of sir, can you tell me what acts as a positive and negative terminal in the working of an electrical appliance, like a
like
personal computer? What is the negative terminal in this?
so in like in your switchboard in which you are
Yeah.
plugging,
Is the
okay,
switchboard negative terminal and the electrical appliance a positive one?
the switchboard has both the negative terminal also, the positive terminal
Yeah.
also, and there is third.
While receiving the electric current, what does it
Hmm.
have?
Okay, it does not matter it is receiving from positive or negative. We
Okay.
need to just complete the circuit. Okay, we just need to complete the
Sir,
circuit. Yes, wait a minute. Let's say your two holes of your switch are like positive and negative, and you are pressing your plug inside this switch. So one is going inside this and one is going inside this. So what it is happening, the current is coming from one of these plug, okay, one of this, and it is going to the computer and it is coming out from this terminal. So it is actually completing a circuit, and it does not matter to us whether it is coming from positive terminal or negative terminal, while current always flow from positive to negative, correct? So if we put this our plug inside this switch, the current will always come out from positive terminal and it will goes to the negative terminal. Also there is a earthing wire also in the switch. Can you tell me the significance of earthing wire
Yeah,
in
the
this?
excess electrical charges
Uh-huh.
are going to be sent to the earth.
Correct.
For example,
So
when we are plugging in the socket or taking the socket out, taking the plug out, there might be some kind of electrical charges present in it, and we might get an electrical shock. For
very
this
good,
to
very
not
good,
happen, the excess electric current is will be sent to the earth.
very good. So the earth always act as ground.
Like
We say at ground or earthing. We say in the language of
you can also see it as grounding,
earth,
right? Because I've also read
we say it as
that
grounding,
as
correct?
grounding.
Correct, correct. That's why we say ground and grounding. We also say it as earthing. So earth in every phenomena act as a neutral body. Whenever there are excess charge or something, these are always supplied to the earth. Okay, so that is very good explanation explained by Karthik, that whenever in some of the appliances it may happen that the excess electric charge may present on the that appliance, and when we touch it we may feel electric shock. That's why there is an earthing plug or earthing wire in your like plug and in your switch, due to which this excess charge flows through this and goes to the ground means on earth. Fine, so you know about earthing. Okay, are you clear that we denote potential or potential as volts? We always represent potential in volts. We always represent ampere in we always represent current in ampere. And can you tell me the unit of resistance? Have you
Ohms,
guys heard about
ohms, sir, as
ohms? Okay,
ohms.
okay, fine, very good. If others do not know, so whenever we write resistance,
sir, it's ohm, right?
yes, ohm. And whenever we like we say 1 ohm or 5 ohms, okay,
Sir, ohm has a specific sign, right?
yes, it has sign. We always represent ohm like this. It is a bigger omega. Okay, this is small omega and this is big omega. So the big omega is the unit of resistance. In terms of words, we say it as OHM, ohm. And when we need to show what this ohm looks like, we always use this sign, ohm. Fine. So resistance has unit of ohm. Okay, let's proceed then. Let me see time. Okay, 42 it is. So I'm starting from here, that we can use another effect of electric current to make another kind of tester. So here we are discussing about the tester to detect small current. So I think I have explained you that earlier in the tester we were using bulb, okay, the bulb. So in order for that bulb to glow, we need to provide an sufficient amount of electric current for that bulb to heat up and to glow. Whereas if there are some substances like we seen about vinegar and the lemon juice solution. So this solution has current, but this current is very small, weak current. We say it as weak current, very small current. So this bulb will not be able to identify if there is a current or not. If we need to see if there is a current, even a weak current, we need LEDs, LED bulbs, the small LEDs. We need LEDs in place of this bulb to detect if there is a current or not. Okay. So here in this text, it is talking about another effect of electric current to make another kind of tester. This another kind of tester is a circuit which has LEDs in it. Okay. And there is a one more kind of tester. So this tester works on the phenomena of magnetic field. Okay. So what happens to a compass needle kept nearby when current flows in a wire? Have you done something like this in your home or anywhere else, that you placed a that you placed a magnetic compass near an electric wire? Have you done? Okay. I too haven't done until now. Okay. So this is the phenomena of compass, that when you place a compass too near an electric wire, this compass will show different readings than the earlier it was showing. So that means the electric current is actually deflecting the magnetic field. Okay. So the electric current, let me give different color. Electric current deflect magnetic field. Okay, you can write this point down, like it is the property of electric current that it can deflect magnetic field. Okay, so that's why we are using a third kind of tester, which is a magnetic compass. So what happened to a compass needle kept nearby when current flows in a wire? Even if the current is small, the deflection of the magnetic needle can be seen. Can we make a tester using the magnetic effect of currents? Can we make a tester using this magnetic compass? I'm asking it again, that we need to we need to test if there is a current or not. And I have told you that electric current deflect magnetic field. Okay, so tell me one thing, can we use this magnetic needle, magnetic compass, to check if there is a current or not? Yes or no? Are you guys there?
Yes, sir. We can.
Yes, sir.
Okay. So we can use magnetic needle to check if there is a current or not. Okay, about LEDs, I have told you that LEDs can be used in this tester. And magnetic field, you read this activity 11.3. This is your homework. This is your homework. You read this 11.3. Right. So this is a table. Have you guys done any experiment in your home regarding this conductor and insulator? If not, whenever you get any time, you should try making small circuit like in that of in activity what 11.2. In this, it has taken a uh, small cap of bottle and it has poured the vinegar or the lemon juice inside this cap and used a small cell. Which cell? This cell. Used a small cell and a bulb attached to it with the help of wire, and then these two terminals. Okay. So when I was small, I used to like break the circuits. Whenever I used to see any circuit, I used to break it and check what is there. Okay. So it is like in the third or fourth class that I broke one small fan out of some instrument, and then I used the two wires from that fan in a cell, and that fan started like turning on. So I did that experiment in third class only. Fine. So the next it is that when the free ends of the tester do not touch each other, there is an air gap between them. Paheli knows that air is a poor conductor of electricity. Can you tell me why it is obvious that air is a poor conductor of electricity? Yes, Manisha, can you tell me why air is a poor conductor of electricity? Manisha, are you there?
Yes, sir.
Okay, tell me then.
Sir, because it contains free ions.
Okay, so what will happen with these free ions?
Sir, if there are free ions, then there will be no conduction of electricity.
But here we are talking that air is a poor conductor of electricity.
So,
Yes, Sarshit.
sir, is it because when the charges move in air, they will get spread because of that?
When charges move,
Freely in air means they could get spread easily.
okay, let me tell you. Like, do you know how sound travel? Do you guys remember how sound used to travel?
Yes, sir.
It used to travel? How it used to travel in a normal air and not in a vacuum?
Yes, sir.
No, I'm asking that how you used to travel in air but not in vacuum. Yes, Rohit. How you used to travel in air, not in vacuum?
Or sir, I kind of forgot that answer, but I remember little.
Okay, tell me what little you remember. Karthik, can you tell me how sound propagate in air but not in vacuum?
So
Sir, it travels
sound is the
in
mechanical wave when it needs a material medium to pass through, and therefore, like vacuum is not a material medium, so it doesn't have vacuum doesn't have any particles, so the
Okay,
sound can't
perfect.
uh propagate its energy through any of these particles when there is no particle in vacuum. And
Perfect. So
so
Sir, what
sound,
I remember is that sound travels from Sound travels through waves.
Okay, it travels through wave. Okay, so what I wanted to hear is that it travels in medium and not vacuum, because medium has medium particles. Okay, it has particles, where vacuum does not have any particles. Vacuum is empty. It does not have air particles, air particles, air particles, or any other particles. Okay, so sound is a mechanical wave. It needs a medium. It needs a medium and the medium particles for it to travel from one place, like from place A to place B. To travel for it to travel from A to B, it needs particle of the medium to carry that energy. Okay, if there are particles, these
Sir,
particles will carry
could I
that
tell you why
energy.
air is a poor conductor of electricity?
Yes,
Sir, is it because that
yes, tell me.
air contains some gases due to which it has free ions, so it's a bad conductor of air? I mean, electricity,
No,
as
if
it's
there
a
are free
mixture
ions
of
in
gases.
if there are free ions, in that case it will be a good conductor. Okay, so let me tell you one thing, that if there are free ions, that means it is a good conductor. But if there are no free ions, let me tell you the example of conductor and insulator. In conductor, what we have in conductor? In conductor, we have free electrons, right? So electron is itself a ion, which is a negative charge, which is insulator. So insulator does not have free electrons. So any material, we call them as insulator if that does not have any free electron or any other free ion. Free ion. Ion are of two types, positive and negative. Negative is electron, positive is proton. So, okay. So from this you can see that if there is a free ion, that means it is a conductor. If there is not a free ion, it is a insulator. Okay, so I was talking about sound, that sound travel needs a medium particles, the material medium for it to travel. Similarly, the electric current also need particles for particles to carry its energy from one place to another place. But in this case, the particle must be ion. For electric current to travel, it must be ion. But in the air, the gases are present mostly in neutral state. The gases present in air are mostly in neutral state, and these gases are very, very far apart. Okay, so that means that if let's say if there is a single ion also in the air, so it won't be able to travel because there it won't be able to find any other ion nearby. Okay, so it must need a contact, like let's say a wire. If this is a wire, in wire the medium particles are in contact from one to another, to another, like this. But in air, air is dispersed very, very far away. Okay, and if there are some free ions, those are also dispersed very, very far from one place to from one to another. Okay, so this is the reason in air there is no free ions. Air does not have free ions. If the free ions which are there in the air uh, are very small. Okay, the number of these free ions is very small, and these free ions cannot conduct electricity in the air. Let me repeat it again if there is some confusion due to my language. So let me say that the ions present in air are very, very small, not sufficient not sufficient to carry electric current.
Sir, can I leave?
Yes. Okay, then we will continue from this point. I Tell me one thing, that do you guys understood this thing, that how electric current, how air is an insulator?
Yes, sir.
Okay, let me hear this from others also. Are you guys clear?
Yes, sir.
Yes, sir.
Okay, Karthik.
Yes, sir.
Okay, fine. Then in next class I will ask you guys about the reason behind this, that how we can
What?
say about if I will ask how
How?
air is a conductor.
Air is a conductor.
Sorry, not conductor, but insulator.
Air is an insulator.
Okay, fine. You can leave.
Sir, air is an insulator of electric.
Electric current, yes.
Okay,
We are
sir.
talking about electric current.
Sir, it's because there are no free electrons in air, and that there are no enough ionization in air.
Correct. This is correct reason. And also from in your surrounding, you can see that if there is an open wire, let's say if there is an wire which is cut from between and it is open, if you do not get electric shock until you touch it,
Yes, sir.
okay, you do not get electric shock until you touch it. If you place your hand near that wire also, then also you won't get any electric shock. Why? Because air is a poor conductor of electricity, that the current which is there in the wire cannot travel from that through air to your hand. But this is not true in case of high voltage wires. Okay, there are high voltage wires which
Is it
carry
because,
so high.
sir, is
Hmm?
it because the wire wire can't store that much of electricity in it? Like
Yes,
when
the
air is the poor
wires.
conductor, since the
Mhm,
electricity is not being able to pass to the air, the
uh-huh,
the electrons are being remained in the conductor. But when there is
yes.
high voltage of current,
Mhm,
even the conductor can't hold those many of electrons, and therefore air has to act as a conductor. Is it so?
correct, very good. This is the reason. So
Sir,
the
sir,
Mhm.
I have a doubt related to combustion and flame. If you could answer it, it's for revision.
Okay, ask me. I will try to answer it.
Sir, I'm sending it in the chat. 1 second.
Okay, others can leave
Yes, sir, I
if you
sent
want.
it.
In this chat only.
Yes, sir.
Okay, when fossil fuels burn in insufficient supply of air, CO2 gas is produced.
Sir, can I say?
How? uh,
Can I
Yes, you
say?
can say. Yes.
Yeah. So when we inhale CO, uh, our blood is gonna be combined with it and is gonna form the protein carboxyhemoglobin, and this is going to block the flow of oxygen into your blood. Like the process of diffusion is corrupted, and since there
Okay,
would be
very
less
good.
oxygen reaching into your blood, and therefore after some time the flow of oxygen into your body would stop and you will die.
Mhm. You will die.
So
Correct.
you see, carbon monoxide creates suffocation.
Correct.
Thanks, Karthik.
Okay, so it won't be CO, but it will be a CO2.
No, sir,
Okay.
it's carbon monoxide.
Yes, sir.
Carbon
Also,
monoxide does.
Monoxide.
yes, carbon monoxide also, and it also the burning of fossil fuels also produces CO2 also.
Yeah.
Yes,
Okay.
sir.
Carbon monoxide and CO2 also. Fine. So
Yes.
CO2 also is harmful for our human body. Why? Can you tell me why?
Sir, because when we inhale the carbon monoxide, like
Mhm.
Karthik said that it will block the flow of it will stop the flow of oxygen it will not let oxygen enter our body, and it will stop giving oxygen in some time, hence leading to our death, sir.
Okay, correct. Very good. So that this is the very good reason by Karthik that the carbon monoxide will stop
Yes,
the
sir.
flow of oxygen, and the oxygen is the necessary need for our human body to work. Even the oxygen is going to from our like the heart is pumping blood, and the blood is mixed with oxygen. So this oxygen is going even to our fingertips. Okay, the leg, fingertips of our hand, and the fingertips of our leg. Okay, so this oxygen is required to every part of our body, and if this oxygen is blocked, then from one to one, like one by one, our body parts won't will stop working, and eventually we will die if we want to get oxygen.
So can we say that rusting and respiration is a type of slow combustion? When they ask in true or false, is it true or false? It's
Okay,
true,
you
right?
are
Rusting and
asking that
respiration is a type of slow combustion.
rusting rusting is not combustion.
I mean, so it
Rusting.
produces a little energy slowly.
Okay, combustion you say when you produce heat, and rusting iron is deposited like, oh, okay, is a combustion or not? Increases the weight, okay, and if it make an object hot or not. Okay, uh, I think I need
Sir,
to
I sent
see
one
on the
more. Could you
internet.
please tell if my answer is right for that one?
Okay, let me first answer to Karthik.
Yes, sir.
That okay, Karthik, do this Google. Like, I do not know about rusting acts as a combustion or not.
Yeah. So,
And what?
according to Google, rusting is a slow combustion.
Okay, rusting is a combustion. Okay, very good. And what was the second part?
It is a respiration, sir. Respiration is a slow combustion, right?
Respiration is the
Respiration of human
chemical.
beings.
Respiration, I don't think respiration is a combustion. Is it saying
Because
in the Google that?
the glucose is being combined with oxygen and energy is released. And also carbon
Okay,
dioxide and water is also released.
okay. Yes, then respiration is like a combustion reaction. The slow combustion reaction producing very less energy. Okay. If you are given two substances in which one will burn
Bye,
immediately and
sir.
other okay, bye. And the other substance takes some time to burn, uh which one according to
Sir,
you
I
has
think the first one will burn. Uh, Sir, I think the second one has lower ignition temperature because it takes some time to burn, and the first one burns quicker since it has high ignition temperature.
what do you mean by ignition temperature?
So, like when the substance catches fire at its highest temperature.
Okay. So in that case the second substance must have the high ignition temperature.
Yes, sir.
Okay. So the ignition temperature
Oh,
means
sorry, sir, my bad. I just checked the textbook. It says that ignition temperature is the minimum temperature required to start a fire or combustion.
yes, correct. So what does ignition temperature mean? That it is
Sir,
the minimum
when the
temperature
substance catches fire at its lowest temperature,
point.
at its lowest temperature.
Yes. So if the like in these two substances, the first one will burn immediately. That means it
So
has
the first
less.
one will burn immediately because it has less ignition temperature,
Yes. And the second one will have
high ignition temperature.
correct. Okay.
Yes, sir.
So this same effect applies in the melting point and boiling point also.
Yes, sir.
So when we say any object has low melting point, that means it will melt at low temperature.
Yes,
If
sir.
we say any substance has high melting point, like the highest melting point is of iron. So it takes more than 1000 degrees Celsius for iron to melt. Okay.
Okay, sir. Thank you, sir.
Okay. Welcome. Bye bye.
Bye, sir. Good night.